Okay, so I am audible to all of you. सब लोग सुन रहे हैं मुझे? Hello, hello. Can anyone respond?
We
I am
can hear
audible.
you. Yes, sir.
Yes, sir.
Okay, ठीक है. So let us start then. So today I will give you an explanation, and those that day we discussed from the notes. Huh? So let us discuss that topic again today. It will be more clear for you. So this is what work energy and power, work power energy. So what you have to do is in work power energy. First of all, that day we discussed what is work, what is power. So work done is what? Force into distance. Huh? So whenever a force moves, force acts on a body, and the body undergoes some displacement, huh? Then what happens? Then work is said to be done. Okay. So work is said to be done, and because of that case only, you get what? Work done. Right. So this was the expression, and then now if you see in certain cases, okay, if you see in certain cases, the force P, the force P does not act in the direction of motion of the body. That means what? The body is moving in one direction and the force is being acted upon in some other direction. Like this one. Then you have to take the component. Right? So what will you take for here? Look. Now force into what? The distance, the amount of distance that the body is moving. If you see in the figures 1 and 2, if you see here and here, what is the difference? The difference is that, what is the difference? The difference is that look at this and this two. So what is the difference? Here the force is acting in a straight path, सीधा act कर रहा है force. लेकिन यहाँ पे क्या है? It is inclined at an angle of theta, right? So for this case, for this type of scenarios, you'll have to take the cos theta component. That means p cos theta. Why cos theta? Because we all know, suppose this one is like this, right? Then if the angle is here, if this is something p, so this will be what? This will be the cos theta part, right? That means this will be what? P cos theta. If this is theta, and what will be in this side? What will be in this side? It will be what? P sin theta. है कि नहीं? है कि नहीं? समझ रहा है? Do you remember these things, students? Hello, do you remember these things? Yes, cos theta and sin theta thing. Do you remember?
Yes, sir.
Okay.
Yes, sir.
Yeah. So this is how you have to assign it. No? So if it is not in the direction of motion of the body, then you will have to take the angle, right? So you'll have to take the angle and then eventually find out the work done. Okay. This is how you'll be finding out. ठीक है? अभी हम लोग क्या करेंगे? तो unit of work we all know.
But here, sir,
हाँ बोलो. हेलो, तुम्हारा सुनाई नहीं दे रहा है. Just ask me.
hello,
हाँ बोलो बोलो, सुनाई दे रहा है, बोलो.
hello.
I'm hearing you. Please speak.
Uh, sir, it should be sin theta. why it
Your noise is a
use
bit
cos
more.
theta?
थोड़ा
Because it's
थोड़ा
opposite direction.
बहुत जोर से नॉइज आ रहा है, तुम थोड़ा दूसरा जगह पे आओ तो, ठीक है, बहुत जोर से आ रहा है
Okay.
नॉइज, थोड़ा दूसरा जगह पे आओ, उसके बाद पूछो, होगा?
Yes, सुनाई दे रहा है?
बोलो, अभी अभी क्लियर है, बोलो.
Sir, ये it should be the p cos p sin theta. Why it is used p cos
कैसे
theta?
साइन थीटा
Because
होगा, तुम बोलो तो.
opposite side है ना, हम लोग we use right hand side p cos theta.
एक बार सोचो तो, इमेजिन करके देखो.
ठीक है, okay, it's yeah, fine.
समझा
हो गया,
क्यों होगा? अभी मैं दिखा था ना तुमको, देखो अभी फिर से दिखाता हूँ, समझो. हाँ,
Yes,
अभी फिर से दिखाता हूँ, समझो. ये देखा, रुको रुको,
yes, sir.
ये देखा, ये चीज देखा. हेलो,
Yes, sir.
यहाँ पे क्या आता
Yes,
है,
sir.
इसमें अगर आएगा तो कॉस होगा ना, तो ये कॉस क्या होगा, हॉरिजॉन्टल होगा. तो बॉडी तो हॉरिजॉन्टल प्लेन पे ही मूव कर रहा
Yes,
है ना, ये प्लेन पे ही मूव कर रहा है ना,
yes.
तो ये कॉस थीटा लेना पड़ेगा. समझा अभी तुम? नाउ इज इट क्लियर?
Yes.
क्लियर और
Yes,
नॉट?
sir.
ओके गुड. So now
Yes,
we'll go
clear,
to,
sir.
okay, good. So now we'll go to the next thing. So what are the unit of work? The unit of work is that joule. The joule means what? Newton meter. So Newton meter क्यों होता है? Because look, the force is what? In newtons ना, and the distance that is moved by the body is in meter. That is why we think it is Newton meter, right? So we take it as Newton meter. Now if it is a higher amount, if you need some more, then we go for kilojoule. Okay, kilojoule when there is kilonewton, the force is in kilonewton, that means 10 to the power 3 newton. Then we will be having what? Kilojoule thing. समझा? So you got the difference when we have to use Newton meter and 1 kilonewton meter. Now look, there may be some questions, define 1 Newton meter or define 1 kilonewton meter. So what is 1 Newton meter actually? 1 Newton meter is the amount of work done when 1 Newton force is acting on a body and it displaces the body by 1 meter. सब अगर 1 होगा, then we can get this 1 kilonewton meter or 1 joule. That means if you have to define 1 joule work done, so what is that thing? It can be said that 1 joule work done is the 1 joule work done is the amount of work done that is when 1 Newton force is acting and when the body is displaced by what? 1 meter. Okay, so this is how we define 1 Newton meter or 1 joule. Then similarly we can define 1 kilonewton meter. ठीक है, so we define those things in that manner only. Now let us do a graphical representation of work. The graphical representation of work, this thing, look. So the work done during any operation. Hello, people, you are hearing me, na? सुनाई दे रहा है ना तुम लोग को? हेलो,
Yes.
हाँ ठीक है ठीक है, अच्छा ठीक है, थैंक यू. तो ग्राफिकल रिप्रेजेंटेशन ऑफ वर्क क्या है? So we have to graphically represent the work done, na? So how it will be represented? Now we have to plot the distance in x-axis axis and the force along y-y axis as shown in figure A or B. So how it is put? Simple. Suppose some amount of force is acting, na? Some amount of force is acting. Maybe if it is P Newton force, so we have to simply put that value of P in the along the x-axis. That means what? Look, if we are putting along the x-axis, that means along this axis. So you have to take it as this value. Okay, so if you are putting it here like this, this value. Hmm. So this value you have to put it. That means what? Along x-axis you have to put this value. That is the value of the force. Now s is what? It is the distance. So you have to put it along this axis. Now this, if you see, this one, here it is a straight line, right? That means what? The force is constant. Why? Because whatever the value of P here, the same value of P is what? Same value of P is here also. That is why we are getting it as constant force. Now why variable force? That means what? Initially the force is different and finally the force is different. So this is how the graphs are being plotted. That is why we are getting in the second case P1 and P2. So in the first case we had P1 is the first force and P2 is the what? Afterwards it is being applied in that manner. Okay, is it clear everyone? So okay, so now what is happening? If you see, since the work done is equal to the product of force and distance, therefore the area of the figure enclosed represents the work done to some scale. Now this figure, that means this one. Now area, you all know, area is what? Equal to length into breadth.
Length to breadth.
Now, so here if you see this rectangle here, this part. So here it is what? One is S and one is P. So if you think L to be L to be P, S to be and B to be S, then if you multiply P into S, that means what? We get V is equivalent to this thing. So if that is why the area is what? This is the area. So it gives what? It gives the work done. So similarly, this area of this graph, this area is known as what? The work done. Okay, and this type of diagrams are called what? Force distance diagram. Now force distance diagram is rectangle if the force is constant, and if it is a variable force then it is a, what is this shape called? Can you say what is this type of shape called? What is this type of shape called? What is this type of shape called? Hello, are you hearing me?
Trapezium, I think.
Huh?
Trapezium.
Okay, good. Anyone else? Those who want to try? So this is, can you hear me everyone? Hello, हेलो स्टूडेंट, सुनाई दे रहा है मुझे तुम्हें? Okay. I guess everyone is hearing me. Can anyone please respond to it? Because
Yes.
okay, then thank you. Actually, I am having issues with my network today. That is why. So is this clear up to this part? Graphical representation of work. Everyone?
Second figure, we use what, sir? Trapezium.
एक बार फिर से पूछो.
In second figure, B,
हम्म.
variable force.
हाँ variable
Trapezium,
में. हाँ ट्रेपेजियम है. तुम तो आंसर दिया ना अभी. हेलो.
half A plus B H.
हाँ इसका एरिया तुम लोग कैसा निकलेगा? हाफ इंटू सम ऑफ द पैरेलल फेसेस इंटू हाइट है कि नहीं? इट्स नॉट. यू विल फाइंड
Yes.
आउट इन दैट मैनर. ओके. So you'll have to find out the area if it is given in the graphical form. Okay, then you will get the work done. Clear? So I guess it is clear for every one of you. So now what we will do is we will try to do two numericals today. So you will have to try it of your own. These are very easy numericals. Can you see it? Can you see the this one slide of the question, students?
Yes.
Okay, first of all you try to solve number 1. Okay, first of all you try. I'll give you 7 minutes to solve it. You have to then respond to me. Can you all try solving it? You have to write the answer in the chat box. Okay, I'll be waiting for your answers. So, students, anyone got any answer? कोई किसी को आंसर मिला?
2250 न्यूटन मीटर आ रहा है क्या सर? ना 22.5 न्यूटन
पे लिख
मीटर.
दो, छत पे लिखो, तो छत पे लिखो, ठीक है, चैट बॉक्स पे लिखो तो आंसर को. Okay, someone. Okay, okay, I got 3 answers. What about others? What about the other people? What about others? Yeah, I'm giving 3 more minutes. Just try to solve it out. Then we'll discuss it. Huh?
Sir, sir,
Hmm. Yeah, say please.
sir, kilometer per hour convert কৰিব লাগিব নেকি sir?
ভাবাচোন এইটো কিলোমিটাৰ পাৰ আৱাৰ কনভাৰ্ট কৰিব লাগিব নে নালাগে? Just tell me, think and tell me. Time is given in what unit? Tell me first that.
Minutes.
Time is given in minutes, na? Yes or no? And the unit of this one. And the unit of what do you call it? Work done is what? Newton meter. Yes or no?
Yes sir.
So you have to convert this kilometer per hour into what? Meter per minute, right? Then meter per minute you convert, and after that only you will get what? You will be able to get the distance, na? Force equal to distance by time. Oh, sorry, speed equal to distance by time. है ना? So distance equal
Yes
to
sir.
what? Speed into time. So you have the speed in kilometer per hour and time in what? Minutes. So you have to do it for meter per hour. Oh, sorry, meter per minute. Eh? And here the time is in minutes. So then only you will get it in meter, na? Distance. Understood?
Yes sir. Sir.
Okay, try it out. Try it out. Try it out. I'm giving you some time. Okay, so I got three correct answers, three wrong, some wrong answers. One gave one answer wrong, the others are correct. Yeah, the others are correct. Okay, so how to do this? Look, I'm telling you now. First of all, it is given what? The speed is given 4.5 kilometer per hour. So if it is 4.5 kilometer per hour, so you have to convert this into what? Meter per minute. Now what? Now, now distance is equal to what? Speed. Speed then multiply time. No? So speed multiply time the distance. So the distance is speed multiply time. So you have to multiply this. That means this thing into what? Time is what? 5 minutes. So you will get the distance then. Then you will get the distance. Now work done. W is equal to what? Force into the distance. So it comes up to be 300 into distance. Now the answer is this one. Wait, I'm showing you. Can you see the solution? So the answer is what? This one. Most people got it correctly. Very good. Well done. Okay. So is it clear for everyone? The numerical is, I think, clear for everyone. Hmm. So now we'll go to the what? The next numerical. So again, the next numerical you try to do it. I'll give you some time and then we'll discuss at the end. So the question is, a spring is stretched by 50 mm by the application of force. Find the work done if the force required to stretch 1 mm of the spring is 10 Newton. Please try to solve this. Did you understand the first numerical, students? Did you understand the first numerical?
Yes, sir.
Yeah, someone raise their hand. Tell me what doubt you are having. Someone raise their hand. Can you please tell me what doubt you are having? Any problem? Someone give the answer as 25. Now look, here you'll have to take the average force. You found out the force for, it is given for stretching 1 mm is 10 Newton. So for 50 mm it will be 500 Newton. So this is the amount of force required for stretching 50 mm. But in this case we'll have to consider the average force. Okay? So you have to consider the average force. Average force means what? That 500 divided by 2. Then only you will be getting the average force. Then displacement you all know only 50. So it will be 250 into 50, not 500 into 50. Okay?
Why, sir, we take average?
Hello? Hello?
Why, sir, we take the average?
Average force. Because if you see here, the spring is stressed by 50 mm by the application of force, right? Now here we are finding out for 1 mm of the spring, it takes 10 Newton, right? Huh. For the
Yes.
next mm, it may not be 10, it may be 9, but we are considering it as the average one, na? That means what, for 1 mm it is 10, for the next 1 mm also it is 10. Like this way we are considering and multiplying it, na? That is why we are
Yes,
considering the
yes.
average force. समझ में आया? That is why we are considering the average force. समझ में आया अभी? Hello, hello.
It, sir, got it.
Okay, understood now.
Average divided by 3 is equal to 250.
अभी समझ में आया? क्या क्या डाउट है? क्या ये क्यों एवरेज लिया? हेलो.
Matlab, sir,
Hmm.
actually doubt is that it has been clearly written that 1 mm of a square spring is in
ये स्प्रिंग है ना?
10.
If you take the
Yes.
total, if you take the force, if the force is overall given, look here it is, the total force is given. It is not given part by part. That is why we are taking it the whole. Got it? But here it is given by part, no? That is why we are taking it by average. You think in that manner only. Huh? That is why we have considered it. Let us write it clearly. Okay? Did you get it?
Okay, sir.
Okay, good. So the answer will be 12.5. Okay? So the answer will be what? 12.5. So I'll show you the answer now. Wait a minute. Can you see the screen? The power thing we'll be discussing in the next class only. We'll do numericals on power on the next class. So here it is what? The force. So we know that the force equal to space 50 mm. This one. Now so average force, that is why they have taken it 500 by 2. That means for one it may be different now. So the average of the all the forces are taken. Then work done is what? Average force into distance. As simple as that. Okay. So now if you see, this is mm. That is why it came out to be this one in Newton mm. You have to convert this to Newton meter so that you can get it in joule. This is the last part which is very important from exam point of view, because many students what they do is, many students tend to forget. Okay, many students tend to forget what? Converting this last part. This is a very important part. Okay, so you'll have to do that part also. It is very important. So I think so it is clear for everyone. And
Yes, sir.
if anyone have any doubt, they can ask me. So if you have any doubt, you can ask me.
Okay, sir.